Welcome to, I think this is the last lab in Chem 85, correct?
It is, yeah.
Last lab. And it, thank goodness. And it takes us 3 stinking weeks to do this, right?
It does, yeah. You get a week of preliminary, a week of practice, and a week of test.
Oh, I like the test thing at the end.
Me too.
In the lab report, it says that they, or the lab write-up, it says that they have to do a lab report plus their little test thing. That's correct, right?
Exactly, yeah. They have to hand in. So on your test, you'll have 4 cations you have to find and 2 anions. If you get 6 out of 6, you hand in your lab write-up saying that you found this 6 missing or.
And this is how you did it?
And this is how you did it, and these are the steps you took, and then you get 10 out of 10.
10 out of 10.
If you did not get 6 out of 6 on your test, then you have to explain why in your lab report, why you did not get 6 out of 6.
Oh, so you still could get 10 out of 10?
You still could, yes.
As long as your explanations are good.
Yeah, legitimate.
Legitimate
explanations.
Okay. Well, so today what we wanted to do is, and in the lab, it has you go through a bunch of different tests. Basically what the purpose of the whole thing, and correct me if I'm wrong, is you get an unknown with different substances in it, with different positive ions and negative ions, correct? And then you go through a series of tests to determine which anions are in there. So you basically maybe do one test, and then depending on the result of that test, it'll tell you whether you get to go down one direction or another direction.
Exactly.
And then you take each of those things and do maybe another test to it. But eventually you'll be able to determine what exactly is in one of those unknowns.
Exactly.
So we get to do this today?
Yeah, we're going to practice on one unknown that it's known to me, unknown to the camera.
Unknown to me?
Unknown to you, actually.
So this could be a surprise.
It will be. It's always a surprise.
And we get to do 2 different things today, I noticed, that we haven't done before.
Yes, we get to centrifuge.
Centrifuge. Or spin things around real quick.
Centrifuge if you're hooked on phonics.
Centrifuge.
Centrifuge.
And we get to decant.
And decant, yes.
I don't think we've done decanting before. Is that real fun?
Decanting, yeah, it's pretty fun.
All right. Well, let's get at it.
Yeah. So what we have, or what you guys will have in your lab handouts, you will have a flow chart. And this is just for your unknowns. Before you get to this stage, you will be doing a whole lot of preliminary examinations where you will be able to tell me, or Jeff, or Nori, what happens when you add hydrochloric acid to silver cations.
Okay.
So we're going to follow the flow chart, and I'll point you in the right direction each time we do this. Is that okay, Leo? If we can, and I can point you in the right direction each time. But what you need to do first of all, you need to make a preliminary observation for your unknown. Okay? And our preliminary observation for this unknown would be that it is a clear yellow solution.
Looks like urine.
In what? Anyways, looks like it does. It's a clear yellow solution.
Clear yellow.
Okay. Now, right off the bat.
This is your unknown.
This is your unknown. Yes. Right off the bat, we're thinking, well, if it's a yellow solution, it quite possibly has some iron cations in it. So,
sure. If
it's a yellow solution, iron. Now, if we're a blue solution, we'd think copper.
Copper.
If it was a green solution, we'd think iron and copper, because yellow and blue make green.
Green.
Yeah. So what you're going to do is you're going to take some of these tubes.
A centrifuge tube?
Yeah, centrifuge tubes. These ones are just, they are as 10 by 75 millimeter test tubes. Just plain simple test tubes, nothing too fancy. Okay. And you're going to need about 6 of them for each unknown. So you're going to take 6 out of the box. Make sure you save your 6, because you only get 6 or 10 Durham tubes to practice with throughout the experiment. So.
Do we have to throw these away at the end?
At the end, yeah. At the very end.
Okay.
And you're just going to take a little bit of your unknown solution and put it in the bottom of your tube.
How many drops?
I'm guessing about 5 drops.
All right.
Okay.
Oh, just a little bit.
Yeah, right. So about that much. Can you see that?
I can see it.
Okay, so just a little bit, about half a fingernail width, I guess you could say. And to that, to our unknown, according to our flow chart, we are going to add hydrochloric acid.
This looks like hydrochloric. Do you want this one?
That is the one I would like. Thank you very much. Okay, now with these, it's really important that you make note of every step that's happening, okay? And it's also really important that you put your lids back on the proper containers. Okay, I say that giggling, but it's true. It's amazing the different results you can get if you put your lids back on the wrong container. Now, obviously, when we added hydrochloric acid to this, we got a solid formed. Or
It does look like it's cloudy.
Cloudy, yeah. So as soon as it's cloudy, you know that there's a solid or some sort of solid in there. So what we're going to do to this is we're going to centrifuge this mixture. Now, your centrifuge is this large round thing that sits in the middle of your bench. Now, these have been known to walk off the benches before.
Walk off.
They walk off
by
the benches
themselves.
by themselves, exactly. So what you want to do, on either side, you're going to put these tubes into the centrifuge, but you need to balance the centrifuge. So just make sure you have a tube on either side. Actually, it works best if you work with a partner. And what you're going to do is turn on the centrifuge, and we're going to wait for about 30 seconds.
Okay, 30.
Actually, we really do have to wait a little bit.
We have to wait 30. All right.
But that's okay. Actually, it's probably better to centrifuge for about a minute, but we're going to wait 30 seconds for the purpose of
About a minute.
of
Okay.
video.
Okay.
Now, with the centrifuge, okay, it has a brake on the top. Some of the brakes are really good, some of them are really bad. If you have to put force on the centrifuge, this thing gets going up to about 6,000 RPM, so it's very quick. So please do not open it while it's going. You might lose a finger. Okay?
Oh, it is going
It
fast
is still going, yeah. So again, close it back up, put the brake on. Eventually you'll hear a click,
It stopped.
and it's stopped. And our solid has now collected on the bottom of our tube. Yeah?
I do. I see a little
There
bit.
it is. So what we're going to do to this, we're going to take a pasture pipette. Just going to take one of these.
A pasture pipette.
Yeah, pasture as in the famous guy that invented pasture pipettes.
How much are these worth?
About $1,000 a piece.
Oof.
So these ones here, actually no, these aren't worth very much, so you can use them and dispose of them. What you're going to do is you're going to decant off the liquid and leave the solid in the bottom. Okay, so I end up with, oops, sorry about that. You end up with liquid in the pasture pipette and a solid in the bottom of my tube.
I'm with you.
Okay,
What do I do with the solid?
the solid goes, we're gonna use in a second. You want to save the decants. You want to make sure you save this because there are more cations in here.
Oh, so we decanted.
We've decanted. That's decanting right there.
It was quite fun.
Yeah, it was interesting. It's fun. It's fun to do once you get to that stage.
So it looks like we've got a ton of test tubes. I'd be fairly organized in where you're putting your test
Oh,
tubes.
definitely. You need to
Okay.
be. You need to be as organized as possible. So right now, this is my decant. What
Yep.
I've decanted off, and this is my solid.
Yep.
Now, according to our flow chart, right now, I've added hydrochloric acid.
Yep.
Okay, and I've got a solid, so I'm going to follow the dotted line. Every time there's a dot, every time I find a solid, I have to follow the dotted line. And what that dotted line means is that I centrifuge.
You centrifuge, but it also means that there's only two of the ions possible that could have formed a solid.
Exactly.
So silver chloride or mercury chloride.
And actually, because we don't use mercury anymore, you can just cross off the mercury on this flow chart.
So I'm sure that in that the precipitate was silver chloride.
Yeah, but we're just going to double check just in case.
Good idea.
Okay, so just in case, we're going to double check to make sure we have silver. Okay, so to our solid, what we're going to add is we're going to add, what is it? Ammonium hydroxide. Okay.
Ammonium hydroxide.
And just drop by drop, and be generous with these, because remember, it's qualitative analysis, which means we need to discover what's in here, not quantitative, not how much. So,
I like these.
yeah, they're kind of neat.
They are sort of cool. Can I have one?
You can have one. You can keep
Nice.
that one if you like. Okay, we're going to mix it up, and what happens to our solid? Well, it goes back into solution. It dissolves into solution.
In the solution. Now I can't see a precipitate there anymore.
Nope, none at all. And now to that, we're going to add nitric acid. And since we added hydrochloric acid in the first step, and we got a solid, if we add nitric acid in this step, we would expect to get a solid back if we have silver. So we add in our nitric acid, and
Oh, I'm seeing cloudy.
voila, we get a white cloudy precipitate formed. Sorry, Jeff.
Well, I can see it.
A white cloudy precipitate formed into our solution. So that tells us that we definitely have silver. We have a silver cation. So once we've discovered that we have silver in there, we write that one down, and we can discard of our
Discard that one.
This one here.
That was the precipitate.
That was the precipitate
But we
form.
still have that other one full of yellow, full of cations,
definitely,
right?
yeah. So now we take our decant from the first step.
No precipitate in there.
No precipitate, just a clear solution. We're going to add, again, we're going to add NH4OH,
Okay.
which
And
is ammonium hydroxide.
And to know which one you're doing, you just have to follow this chart. So right now we have possibility of having calcium, copper 2, aluminum, or iron 3 in there.
In here.
Correct?
Exactly. And so when I add the the ammonium hydroxide, you'll notice something happens. It kind
Oh.
of separates out a little
It's a
bit.
flatulent, no, not,
A flocculent.
a flocculent level.
A flocculent precipitate.
It's a flocculent. Oh, I can see that.
So what I'm going to do, in order to get rid of my flocculants, I'm going to take a pasture pipette and just stir. And you'll
Oh,
notice
you're
something
stirring.
happen here. It gets really, really warm. Okay? It gets really warm.
Oh, it is warm.
And what happens is you'll notice that the solid comes out into solution. And you can see it. It's like a clear jelly-like solid.
Yeah, yeah, yeah.
And there's also some yellow and orange solid in here. So basically what we know that has happened now is that we have a solid formed.
Yeah, that's different. Different than a precipitate like the last one. You could,
Oh, definitely.
you could tell the other one was a precipitate, sort of a white solid. This one, it's a different kind of precipitate.
Yeah, this is a jelly-like precipitate.
Do we get to centrifuge again?
We do. As soon as we get a solid formed, right away we know we need to centrifuge. So we stick it in the centrifuge,
One
crank
minute.
it on,
Don't make it walk away.
and don't let it walk away. We still have our balancing tube in there.
All right.
While we're doing this, we can replace our caps. Also, the other thing that drives the lab technicians here crazy is if we don't put the bottles back in the same order. It's one of their anal retentivenesses.
A pet peeve thing?
Yeah, so make sure you put your bottles back in the same spots where you found them.
Just mess one up, just to mess them up. No, don't do that.
Okay, so once we've centrifuged this, again, centrifuging brings the solid to the bottom. Oh, sorry.
Oh, get the mic close to that. That would be the brake.
That's the brake.
Oh, you could have used this one. Oh, you're going to decant again.
I'm going to decant again. I wouldn't want to mess yours up. So, I've got my. Now you'll notice that sometimes when you stop this centrifuge, sometimes what happens is you get the solid comes up here. It gathers at places. We'll put it that way. It gathers.
Yeah.
Now, what we're going to do here is we're going to try and decant the fluid, but leave the solid.
Well, that could be tough.
Yeah, it's a little tough. You need a surgeon's mind.
So you're getting all the yellow stuff out.
I am, yeah, and I'm just leaving the solid precipitate in the bottom.
You've done this before.
A few times.
And you're knowing which one you're putting the decant in.
I am. I'm keeping mental track of it. Okay, now sometimes you will lose a little bit up into your tube. It's not a big deal as long as you have a little bit of solid left in the bottom. Which we don't. Sorry about this. Should have been more careful. That's okay. It'll still work.
All right.
Okay, so now we've got our solid in here again.
It doesn't look much solid.
No, there's solid, but you can see the solid on the sides, the jelly on the sides there.
I can see the jelly on the
So we
sides.
do have some solid left in there. What we're going to do to what our solid here is we're going to try and figure out whether it's aluminum solid or iron solid. So
Oh, let me see
on
here.
our chart,
Oh, I see. Add ammonium hydroxide. The decant thing comes over here. No, the decant is on this side. Oh, I should show.
Yep.
The decant would be on this left side, and the precipitate's on the right side. So now we get to choose between aluminum ions or iron ions.
exactly.
I'm with you.
Now what we're going to do to this solid is we're going to add sodium hydroxide.
Okay.
And what should happen is the aluminum cations should go back into solution, and the iron cations should remain solid.
Should hang on. Oh, and you're putting that stuff on the edge so it sort of slips
So it
down
slips
there.
down there, and then we should get A, and you can see that the iron has stayed out of solution and the aluminum has gone back in. So we have again, we have a jelly-like precipitate formed. Now it's important at this stage, again, we still have a precipitate, so what we're going to do is we're going to centrifuge again. Oh look, there's lots in there. Oh, we're gold.
We're good?
Yeah, oh yeah.
All right.
So again, at this step here, it's important that you centrifuge very, very well. So we're going to leave this one for a little bit longer.
To separate the two.
Separate the aluminum from the iron.
Gotcha.
Now,
Gotcha.
while we're waiting for that to happen, again, you can see here in this solution, we still have lots of solid there. So this is what we decanted off.
Right.
If you find that you're getting solid back into solution, you can centrifuge this again and then decant it again, just to double check.
All right. That
Okay.
makes sense. So we've got a couple more steps here. Now you're going to add something else to this?
Yeah, we're gonna take away our decant again.
Boy, you need lots of those. And you get to throw these out at the end?
Well, after you've done all of your examples.
Right.
Not right away, but after you've done your practice, you will get to throw them away. Well, there it is. Excellent. Okay, so now we have.
Oh, that's tough to see, eh?
Yeah, it is a little tough to see sometimes. If you're having trouble seeing these, you can always just take more. So just take more and use more in your solution. We're going to decant off most of the liquid here, but we're going to leave a little bit because the iron in the bottom is a jelly-like precipitate and it will come up the tube. Okay, so now to prove that this is iron solid in here, what we have to do is we have to dissolve it first. So we have to dissolve it back into solution. And what we're going to add is 6 molar hydrochloric acid again. And at this point, you should see that you get some steam rising, and of course the iron is dissolving back into solution.
I gotcha.
Okay, and from there, we're going to add something called potassium ferrocyanide. Now, potassium ferrocyanide in the presence of iron turns a bright blue. But in this case, we're probably going to get a yellowy blue color.
Oh, I see a bit of
at
blue.
the top.
Yep.
Okay, so that proves that we have iron. So now we know for sure that we have silver cations in solution and that we have iron cations in solution.
Then you're going to go back to your decant and do more tests on that and more tests until we determine exactly which of the ions are in there.
Exactly. So now we've got our decant, and now just to show that we actually do have aluminum in here as well, I'm just going to add hydrochloric acid once more.
And what should we get?
A flocculent precipitate. I know that's your favorite word of the day.
It is my word of the day. You get some flocculants.
A flocculent precipitate.
You're pretty good at putting the lids back on. I see flocculent level right there.
On an oily, can you see that LEO on there? You see a flocculent precipitate forming in the middle. Okay, so now we know we have 3 cations in this solution. We've got 3. We've got aluminum, we've got iron, and we have silver.
Right.
The last test we're going to do is a flame test.
Oh, flame.
Yeah, we get to, yeah.
Do we get to use a Bunsen burner?
We do, actually.
Oh, I didn't know that. This is exciting.
So what I'm going to do, Jeff, I'm just going to switch you spots.
Oh, sure.
Okay. Now, in order to do your flame test, there's a couple of ways to do it. The way I like to do it is using just my own eyes. I mean, there's lots of different ways to do it. The other way to do it is use cobalt glass, and it depends on your instructor's preference whether or not you want to use cobalt glass or just your own eyes. If you can do it, if you can eyeball it, it's great. The cobalt glass, what the cobalt glass will do is it will eliminate any possibility of mixing it up. So I don't have a cobalt glass piece here today, but there will be some put out for you on the side. You hold the cobalt glass up, and if you see orange, you know you have sodium. If you don't see a flame, you know you have potassium. So
I get you.
So with this, the easiest way to do it is take a beaker to the fume hood. Okay, make sure when you're using the Bunsen burner that you take off your gloves.
And you're going right back to the original
solution, yeah.
Not to one of your decants.
No,
Okay.
This is the original solution. You're just going to put a couple drops on the end of a loop.
End of a loop.
End of
So
the
you
loop.
got it hot first?
Yeah, I cleaned it off. I got it very, very hot until there's no more flame. And now what I'm doing, I'm just putting it on the top of the little blue flame in the middle, And what you'll see is that for a sodium cation, it will burn very, very bright orange,
Oh, like we just saw.
like we just saw there.
Oh, and if you want, you can throw a bit more on there.
Oh, you can throw on as much as you like.
Okay, and if it's a,
If it's a potassium cation, it'll burn purple. And that's why the cobalt glass will eliminate the flame.
I
This
get
is
you.
tough to see out here. Normally we do this in the fume hood.
I'm seeing orange. A good orange, look at that.
Bright orange flame. So our cation in this case would be sodium.
Got to be sodium.
So in this unknown solution, we have aluminum, iron, sodium, and silver, and that's it.
All right, and those are our cations.
Cations.
And then we do similar kinds of things for our anions.
Exactly.
All right. So that is about the lab for today. It's taking an unknown solution and doing various tests on it, calculated tests, to determine which ion, either a cation or an anion, exists in that solution.
Exactly.
Thanks, Scott. That was great.
Thanks, guys.